Hello, and welcome back to Shiksha DaCosta. Today we're going to review the unit using linear systems to solve problems. In this unit, we learned how to find and how to interpret a point of intersection between two linear relations. And hopefully by now you can model and solve a problem that involves two straight lines intersecting. In this unit, we learned that a point of intersection is a specific coordinate where the two different linear relations have the same x and the same y. Now, there are four situations that you could have a pair of linear relations in. If those two linear relations have the same slope and the same y-intercept, what does that look like? Probably like the same line. And you can see there are infinite points of intersection between the blue and the red line here. If, however, they have a different y-intercept, they might look like this. These are parallel lines. And these two lines will never, ever intersect. So there will be no point of intersection for any two lines that have the same slope but a different y-intercept. If, however, the two lines have different slopes, whether they have the same y-intercept or not, they are going to intersect somewhere. The two lines with different slopes can never have no point of intersection, especially if they go on, because they go on in both directions towards infinity. So for linear relations that are in slope-intercept form, remember that the slope describes the rate of change. The y-intercept describes the initial value. Well, if the slopes between those two linear relations are different, those two will intersect at a very specific point. That inputting that value of x at that point will give you the same output, the same value of y for both linear relations. You can graph them, and that might really help you to find the point of intersection very quickly. But in this unit, we explored how to find it without needing graphing technology. If you do need graphing technology, when you're encountering a problem and you can create some linear relations out of it, for example, in this one, this is a relationship between the cost and the number of gigabytes used, you can graph those two lines once you've come up with their equations. You can do that by hand or using technology. Looking at the graph, you can see that the points might intersect. Every pair of lines will intersect at least once. And this can be interpreted to mean that when the y value, when the independent variable, when the x value is between a certain interval, one of the lines might be lower than the other. And we see that happening in three different segments here. However, at the points of intersection, those two linear relations have the exact same output for that input. After we dismissed graphing technology, we moved on to learning substitution. To substitute a linear system means to take your pair of equations, isolate one of the variables in one of them, and take that expression and replace and substitute it in to the other equation. Using your new equation, you can expand, simplify, and then isolate for the unknown variable. And then finally, you can take that variable and plug it right back into the original equation you had to find the value of the other variable. Now that you're done all that, you can, of course, check your work by taking either of the two equations, plugging in the values that you know, and making sure that they check out. That the left side equals the right side. After that, we learned elimination, which is yet another strategy to solving linear systems, where you choose a variable, you multiply the first equation by the coefficient of that from the other one, and vice versa, and that makes their coefficients equal. And that's really what you're looking for. You don't necessarily have to multiply one equation by the other. You just need the variable's coefficient to be the same in both equations. If they are the same and they have the same sign, you can subtract them, and that term will disappear, leaving only one variable. This is why this is called elimination. However, if they have different signs, then instead of subtracting, you can just add them, and that will leave you in the exact same situation. Once you have an equation that only has one variable, simply solve for the value of that variable and plug it back into one of your original equations to find the value of the other. A linear system, whether you're solving it by substitution or elimination or even graphing, recognize that it could have 0 points of intersection if, or in other words, 0 solutions if those two lines are parallel. It could have one solution if those two lines are askew or non-parallel, or it could have an infinite number of solutions if they are the exact same linear relation when graphed. These systems frequently appear when we're trying to find an optimal or balancing point in a scenario. They're present when we're comparing different service providers that have a base rate that they charge or a fixed amount, as well as a rate per usage. Linear systems are present when you're finding break-even points in businesses. And they're present when you're trying to find the exact amount of two different mixtures so that you can combine them to reach a perfect concentration. And they're actually present in many, many more situations than just these. When you are confronted with a situation that has a linear system present in it, make sure that you define the variables that are present. And that will avoid you getting confused later on in the problem. Use a let statement. For example, let x equal the amount of cocoa in this mixture. When you're done, make sure you write a final statement that summarizes the problem just to reassure yourself that you understood it correctly. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.